Okay, so now let's go over different calculations of solutions. So we looked at the long list before, so now let's kind of do a calculation of molarity versus molality. Okay, we've seen molarity before. This is a big M. Remember, this is moles per liter. So this moles of your solute versus liters of your solution. So if we're looking at salt water again, this would be moles of your salt versus liters of the whole entire mixture, if you want. This is dependent on temperature because the volume increases with temperature. So remember we learned with, like the ideal gas law, things expand as they get hotter. So if you heat this up, this is going to change the molarity because the liters, the expansion of the solution, okay? So that's why sometimes people will give it a molality because it's not dependent on temperature, it's moles per kilogram. So it doesn't matter how much you heat something up, your grams will always stay the same. So this one is moles of solute, just like the top of it here, but instead of dividing by liters of solution, you're going to do kilograms of solvent. So that would be kind of like kilograms of water. Okay? So that's why you would use one versus the other. If you're going to be heating and cooling it up and you want a consistent measurement, molarity is not a very good one because it changes with temperature. So if you want something that's consistent no matter what temperature you're at, you'll use molality. I will say that most of the time things you're going to give a molarity, that's what you're going to see most often because it's just given at room temperature. Like at room temperature, this is the molarity, okay? But occasionally you do see molality, and this is given usually as a small m. So let's do an example calculations of each. I pulled a big problem up, and we're going to be working this out. Not here. Here it is. We're going to be working this out throughout the next couple presentations. So a solution is prepared by dissolving 28.4 grams of glucose and 355 grams of water. The final volume is 378 milliliters. We're going to calculate molarity, molality, percent by mass, mole fraction, and mole percent. Okay, so we're going to look at all of those. Right now I just want to look at molarity and molality. Okay, so let's put down all our data. We have 28.4 grams of glucose. Okay, so let me write that down. Come over here. Glucose, I think, was 28.4 grams. Okay, and let's see what we have here. $355 grams of water. So I'm going to say H2O equals 355 grams. Okay, and we'll say our volume of the solution, so our final volume was, I don't remember, let me look it up, 378 milliliters. 378 milliliters. Okay? So I want to give you, glucose is just a sugar, so we're looking at dissolving sugar in water. And if you look at the molecular weight, if you add up, you have 6 carbons, let's see, what was it? Glucose is 6 carbons, 12 hydrogens, 6 oxygens. When you add up the molecular weight of all of those, you will get, let me see, I wrote it down. I wrote it down somewhere. 180. Okay? So the molecular weight of glucose, let me put that down here too. Molecular weight of glucose, and that's just sugar, is 180 grams per 1 mole. Okay, so let's first do molarity. Molarity, it's big uppercase M. And that's moles of solute versus liters of solution. Okay, so let's see what we have here. Our solute is glucose, that's what we're trying to dissolve in the water. We have it in grams, but we need it in moles. So our first calculation is to get moles of solute. Okay, so we have 28.4 grams of glucose. I'm going to put big G for glucose. Okay, and right down here, I told you that is 100 grams per 1 mole. We have grams right here, so we need to cancel it out. So we put 180 grams of glucose down here, and then on top we'll go 1 mole. This is from the very beginning of chapter 1 or 2 in General Chemistry 1. Anytime you go from a gram to a mole, you use the molecular weight. You know to put grams down there to cancel it out. So when we divide these by each other, 28.4 divided by 180, you should get about 0.157 moles. So 0.157 moles of glucose, okay? So now we have moles of solute. Okay, we need liters of solution. Here's our volume. It's in milliliters though, so we need to convert this to liters. So let me put, this was our moles of solute here that we just calculated. Let's now find our liters of solution. So we have 378 milliliters. Okay. I don't want milliliters, I want liters. So I can put milliliters down here, so it'll cancel. Liters on top. So think, how many milliliters per 1 liter? That's 1,000. 1, 2, 3. So we divide this out, and we'll get 0.378 milliliters. Okay? So all I did there is just put everything in the correct units that I need. Now let's divide these like it has in the formula to get molarity. We use a different color. And I'm going to actually do it up here. Okay, so moles, we have 0.157 moles. And we have 0.378 liters. Oh, this is not milliliters, sorry. Liters, I just realized that. Okay, and when you divide that out, you should get let's see, 415. You just put uppercase M for molarity. So that tells us in 1 liter of solution, there is 0.415 moles of our solute of sugar. Okay, so that's what molarity tells us. Now let's look at little m. Little m, this is going to be our molality. Okay, so let's put the formula for a molality. That would be moles of solute over kilograms of solvent. Okay, let's see what we have here. Change the color again. Blue. Okay, do we have our moles of solute? Our solute is what we're dissolving in, so it'd be our glucose. And you see right here, we already figured out our moles of solute right here. So that would be 0.157. So I can put over here 0.157 moles, because we already calculated that. We don't have to do it again. But we do need kilograms of solvent. Okay, so we have up here, we have water, which is our solvent. That's what's doing the dissolving. Okay, we have 355 grams, but we need it in kilograms. So we're going to put 355 grams. Grams at the bottom, kilograms on top. So they cancel. How many grams in 1 kilogram? 1,000. So if I divide 355 by 1,000, I'm going to get 0.355 kilograms. Now I'm going to come over here and I'm going to put this into my formula now. 0.355 kilograms. Notice I have moles over kilograms, which is my units here. So now I'm going to divide this and I will get 0.442. Little m for molality. So notice, let me box that. These are actually very similar numbers because, they always will be, just because you usually don't put a whole lot of your solute into your solvent, okay? But that's how you calculate molarity, and this is how you calculate molality. So be sure when you read a problem in your homework, you look very close. Is it molarity or molality? They're very similar in name, so it's pretty common to read the name and then accidentally, calculate the wrong one. So just molarity is moles per liter, and molality is moles per kilogram. Okay? So in the next podcast, let me just kind of see if I can erase all of this. Delete. Awesome. Okay, in the next podcast, I'm going to leave this data up here so we can still see it. And let's see what we're going to calculate next. Actually, I think we're going to do percent by mass kind of thing. So we'll look at that.